What was Tesla talking about? Invisible power? This light bulb has no battery, no wires, no hidden electronics. Yet somehow it's glowing. How does that work? Over 100 years ago, Nikola Tesla believed electricity wouldn't need wires at all. He imagined a future where power could be sent invisibly through the air. Most people thought he was crazy, but was he? Today, we're going to build one of Tesla's most famous inventions, completely from scratch, and then use it to reveal something you normally can't see: the invisible electric field. Everything starts with a simple plastic tube. It's 2 inches in diameter and 2 feet long, with 2 end caps. This will become the secondary coil. The problem is, we need to wrap about 800 turns of wire around it. Doing that by hand would take forever. So, let's build a winding machine. We add bolts through the 2 end caps with washers and nuts. Add the end caps to the tube. Put a drill in a vise. Then attach the drill chuck to one of the bolts connected to the end cap. And now the tube spins like a giant spool. Much easier. With lots of coated copper wire, 2 rolls of it, we're just going to guide the wire while the tube rotates. It's important that the loops don't overlap or leave gaps to ensure we get a uniform electric field. 800 turns later, our secondary coil is ready. Next comes the primary coil. Unlike the secondary, this one uses thick copper tubing. And because this tubing is thick and heavy, we need to build some supports. A few pieces of plastic, designed to place the primary loops far from the secondary. Some carefully drilled holes, so the tubing can snap neatly into place. Now cut out the supports on my trusty bandsaw. And everything comes together on a plastic base. The secondary mounts in the center, using one of the bolts to secure it. Primary supports attach into the corners. We use a glue gun to make this step fast and easy. The copper tubing forms 3 large loops around the secondary to induce the high voltage. Why tubing? Because huge currents will flow through this coil. The thicker conductor keeps electrical losses low. Now it's finally starting to look like a Tesla coil. Cut the tubing so the 2 ends are close together for the circuit. None of this works without a driver circuit. In our case, powered by a 24-volt DC supply. And we add a switch to control it. The key to this circuit is a power transistor. It's going to get really hot, so it's important we have a good heatsink like this to protect it. We're going to attach the transistor to the heatsink and then anchor it to the base. We solder the transistor collector lead, that's the one in the center, to one end of the primary. Then the transistor emitter lead and connect to ground. That connects right now just to our power supply. The bottom end of the secondary coil connects to the transistor's 3rd lead, that's the base. We now add a blue LED for a visual clue that the circuit is oscillating. Solder in a large capacitor to help with the oscillator circuit. Connect the other end of the primary to 24 volts. Add a resistor to limit the LED current. And we have completed the driver circuit. It's not pretty, but it's really important that the connections are very short. That helps with the oscillation and also minimizes any stray currents. Now something incredible is about to happen. The primary produces a rapidly changing magnetic field. That field induces voltage into the secondary. The voltage resonates, building higher and higher until more than 10,000 volts appears at the top. That's where we attach this metal sphere for cool discharges. Moment of truth. The blue LED lights, that's a good sign. The coil is alive. Now let's test with some metal strips, and there it is. It's really producing high voltage, 10,000 volts. Electricity jumps straight through the air. Pretty cool. If you decide to build a Tesla coil, be safe and don't touch the discharge point directly or get too close. Although you may not feel anything, the high voltage, even at tiny currents, can cause damage. Our bodies are not sensitive to the ultra-high frequencies, but can cause serious internal burns. Here's the strange part. Watch this. No wires, no contact. Yet the bulb lights. How does this work? Inside this little bulb is neon gas. Normally it doesn't do much, but expose it to a strong electric field, like ours, and the gas begins to glow. What if we use this tiny bulb to detect the invisible field surrounding the Tesla coil? Lots of them. To create a detector, I made a grid with evenly spaced holes and placed a neon bulb into every one of them. All 117. Now we need a way to move the array smoothly and precisely. So let's build a scanning machine. 2 rails, a moving platform, and a battery-powered actuator. Here's the grid we created. Now to attach it to the actuator platform. We're ready to put the unit in position near the Tesla coil and do a quick test to make sure the array moves as planned. Yep, it looks good. Now for the experiment. Turn on the Tesla coil. Move the detector array towards the coil. Again and again. Each pass records another slice of the invisible field. If we combine all those images together, something amazing appears. For the first time, we can actually see the electric field surrounding the Tesla coil. This invisible pattern is what was lighting up our wireless bulb all along. Here's the view from above the Tesla coil. Tesla dreamed that one day entire cities could receive electricity without wires. It's a fascinating idea. But transmitting large amounts of high voltage energy through the air also raises important engineering and safety challenges. Strong electric fields can interfere with electronics, waste energy, and at sufficiently high exposure levels may pose health and safety concerns. That's one reason modern electrical grids rely on wires to route high voltage rather than broadcasting power through the air as Tesla imagined. Still, Tesla's experiments forever changed our understanding of electricity, and over a century later, they're still mesmerizing. Learn more about quirky Tesla and 3 other brilliant scientists whose ideas change the world. Click here.